Working with facet geometry is not always straightforward. There is sometimes a need to clean up the imported data. In NX12, we've got a new cleanup facet body command which we will take a look at in this demonstration, together with some of the new selection techniques we can employ during our work with faceted bodies. So on the screen we've got an imported lightweight facet sheet body that's been imported into NX. As you can clearly see, the quality of the facet body that we've imported into NX leaves a little bit to be desired. So we're going to use some of the new tools in NX12 to clean up this facet body so that it's able to be reused for other modeling functions. As this is just a simple lightweight facet body, we need to convert it to a convergent body to enable us to use the new cleanup tools inside of NX12. Following the conversion process, and due to the poor quality of the original facet body, a number of convergent bodies have been created. This in itself is a type of cleanup, as it's isolated all of the unconnected facets, allowing us to delete them. And so we're just left with the geometry we need. So the first task will be to improve the quality of this geometry. And we can start this process by filling in all the holes. And there's a dedicated tool inside the reverse engineering application of NX that specifically does this. After selecting the facet body, we use rectangular selection to make sure all of the holes currently in the facet body will be filled. As the selection process deems the outer boundary of the facet body to be a hole, we need to deselect that, as we don't want that to be filled. On applying the command, we're presented with a warning to say that the holes cannot be filled, so there still must be some underlying issue with the facet geometry. Historically, it's been down to the experience and skill of the design engineer to find these imperfections within the facet model and then eradicate them. This whole process can be quite time consuming and results in the design engineer visually inspecting the facet body and removing imperfections as he goes, and utilizing tools such as display facet edges to get a better look of exactly what's going on with the facet body. So some imperfections have been removed and we can again try to fill all the holes. Unfortunately, we get the same warning that we're unable to fill the holes. So it means the design engineer will need to go back in and try and find out if there are any other further imperfections he can remove. As previously mentioned, this can be quite a time-consuming process. And what the design engineer really needs is some analysis tool that would automatically show him where the problem areas are. In NX12, we now have such a tool, which automatically illustrates the areas of concern. Let's take a look at it in action. You can see in the NX12 reverse engineering application a new command for cleanup facet body. We will use this to analyze the facet geometry and visually feedback any areas of concern. We simply set all the checks to analyze, select the facet body and then preview the results. Notice the color-coded legend illustrates the problem areas with the current facet body. This new cleanup facility also has the ability to repair the geometry. However, in this case, I want to have a little bit more influence on the transition in that area. So I'm going to use the feedback to allow me to visually snip away the problem conditions. Notice I used one of the new facet selection methods in NX12 to snip away the offending geometry. So now let's reanalyze the geometry and see if we've been able to improve the quality of the facet body. As you can see from the legend, we've now been able to remove all the imperfections from the facet body, and we can now continue with our process of filling in all the holes. This time the command completes successfully, and we can now move on with further refining of the facet body. Refining can take many forms, but in this particular case we're just going to look at how we can smooth a particular area of this facet body, and again using one of the new paint selection techniques inside of NX12. So I use the rough brush to paint a boundary of the area I want to select, and then I use flood fill to complete the selection, and on applying the command the area is now refined. So just to recap, you've seen a process here where we can use the new cleanup facet body command in NX12 to automatically analyze and repair problem facet geometry. You've also seen how we can use some of the new selection techniques within NX12 to make the selection of facet geometry a lot more streamlined and straightforward.